My name is Anton. I'm the co-founder of Fatom protocol. You can see the name of the protocol on your screen. Fatom is the DeFi protocol. We built it on XDC chain. XDC is a layer 1 EVM compatible chain. You can read about XDC after I'll finish talking. It's a really cool chain. It's really fast. TPS is huge. So we encourage everyone to build on this chain together with us. And I don't want to, to talk a lot about our technology. Mostly, this webinar is about encouraging you to build something with us. So just speaking just a bit about Fatom. Fatom in its core, it's the stablecoin, the stable asset, over-collateralized. It's collateralized at the moment with XDC. Later, we can bring another assets. XDC is enterprise-focused chain, means the purpose of this chain is to bring institutions, enterprise, and build something with them and for them. XDC has subnets aside from the main chain, so main chain is more for the retail users. Subnets is more for institutions users. So about FXD stablecoin, we are building stablecoin just because we vision it as a beginning of the network ecosystem, beginning of DeFi ecosystem. And for DeFi ecosystem, we need some stable asset, like for example, DAI is this asset for Ethereum. So FXD stablecoin is this asset for XDC. What we are going to build next is the full-scale lending, where you will be able to collateralize other types of the assets, like real-world assets, tokenized gold, ETFs in various places like Singapore, Hong Kong, ETFs on US Treasury bonds, named USTY. It's already signed and tokenized on XDC. So we are going to bring it into the protocol, use them to borrow our stablecoin, and use the stablecoin in, for example, in the vaults we are building, or in other solutions you can find on XDC network. Aside from stablecoin, we also have decentralized exchange. We have the governance, means we are decentralized protocol. We operate over DAO. You can get your FTHM token. It's already live. You can find it on Bitrue. FTHM token can be used only for, for voting in the governance. It will never be used for collateralization purpose. For collateralization, we are going to use only XDC and real-world assets. Talking about FXD, you can think about, some main components of it. The biggest one is, of course, the CDPs. As CDPs, the borrower can come, collateralize their XDC, and borrow some FXD. But yeah, for example, you can use $100 in XDC, but you will be able to borrow just, for example, 75 FXDs, which is based on your loan-to-value ratio. Also, we have the stable swap, which helps us to maintain the peg. We have the flash loans, which gives more opportunities for arbitrageurs on our DEX, on other DEXs in XDC and other centralized exchanges. Liquidation model is also decentralized, but we have the whitelisted pool for liquidators, and we are going to onboard them on a whitelist basis. So I think I can talk more about Fatom, but I want to encourage you to build something with us. So on Earth Global website, you can find all the necessary links for you. You can find the links that will lead you to XDC information, to XDC mainnet, testnet, developer forum. Also, you can find our website, our white paper where all the technical moments are described, our GitHub where you can find all the open sourced work, means we're fully open sourced. Links to our DApp, links to our stablecoin on the mainnet, links to our stablecoin on the testnets, and also we built some CDKs for TypeScript and Solidity to make it easier for you to work with our protocol, to borrow stablecoin, to track positions, to build front-end applications. Also testnet for offset, RPCs lists for mainnet and testnet. So this is a Fatom website. You also can check all the information. I will not really stop here. Our white paper is on Gist. You can read all the technical moments about how we are maintaining our protocol to be over-collateralized, how we implement fixed spread liquidation strategy. You also can find the information about, well, fixed spread liquidation strategy, about our stable swap, how to do the flash mint. You can check about our DAO model, voting model, how DEX works, pretty much Uniswap works. Check the most common user flows and token distributions, etc. Also, please check our GitHub when you will start building. You can find it insightful. You can check our core repositories here in the pinned section of the GitHub page. Smart contracts for the stablecoin, frontend application, SDK in the TypeScript. You can also check our application. You can find it on dev.fatom.fi. Also, demo application on the testnet. So you can check for FXD. You can check example how you can stake FTHM and vote for the governance. You can check on DEX. But the most important thing is, of course, stablecoin. You can open your position. For example, I want to use 500 XDC tokens, and I want to borrow, let's say, 10 stablecoins. Means I can go more, but I cannot. I need to be over-collateralized always. If position will become under-collateralized, if it will be at risk becoming under-collateralized, it may be liquidated by the liquidators who will repay stablecoin by taking the collateral back on some small spread, which will make them the profit. So, for example, I want to borrow 10 stablecoins. I can click on open position. Wait just for a bit. Hope it works. It should be very fast, but network here is very bad. So let's see when the transactions will pass for me. But transactions are minted like each 2 seconds. So here you go. You can see my position: 500 collateral, 10 FXD. Safety buffer is 52%. Position is pretty safe. And I can manage my position. I can repay it. I can top up it or repay it partially or fully. When I'm repaying it, I need to cover some interest, which is accruing on my position. To incentivize protocol, liquidators, FTHM holders community. So I repaid my position. Hopefully it disappeared. Again, we will be launching more projects for Fatom vaults when you will be able to collateralize, borrow FXD, and use FXD to get yield on FXD in the stable asset. Also, you can check our stablecoin in BlockScan, which is Explorer for XDC or for Apothem testnet. You can check our NPM model for TypeScript, named Fatom SDK. It's pretty much easy to install it, to import all the services you can use, for example, pool services, position services, proposals, stable swaps, etc., and use those functions in your application, in your front-end application. Also, we have Solidity SDK. This targets mostly to abstract your proxy wallet. So it will be easier for you from your application, from your Solidity application, to open new positions, close positions, to grab some information about your positions, etc., about your debt. Please check possible public RPCs for XDCs on chain list. Chain number is 50. And for Apothem testnet, Apothem is a testnet for XDC. You can check for the chain number 51 on chain list. That's pretty much it. Means we are the sponsors. We incentivize people to build something on XDC, and the huge bonus to build also something that will utilize, for example, our stablecoin in your work. We have $10,000 in the prizes, free places, so you can check also the recorded workshop there. Check all the links, please. Let's build together. And your questions. I think everything is pretty clear. Okay, thank you very much. Hope to build together.
Guys, hello.
Huh?
Silent workshop this is, so people will going to hear your voice through headphones or
Oh. Oh. Okay.
you'll get feedback, your voice feedback from the speaker. So you
Interesting.
also know okay, you are getting heard.
Oh, why'd you set it up that way? I'm just curious.
Just like
All right, welcome. Thanks for stopping by. Today I'm going to be speaking about how to find the right idea in crypto. Is that good? Too close? Push it back? Oh, a little close. Okay, thanks. There. Today I'm going to be speaking about how to find an idea in crypto. It sounds like an easy topic, but it's actually quite difficult. And so I'll walk through some of the steps in finding the right ideas in crypto, and then I'll also talk about how to find a co-founder. I'd love to see a raise of hands for those that are looking to start a company. Okay. It turns out hackathon is a great way to find the resourcefulness that you're looking for in other co-founders before you start a startup. It's like a great stress test, so I'll walk us through some design exercises as well. So I'm Imran. I'm one of the founders of Alliance, which is a crypto accelerator program. We've had startups like Tensor, which is an NFT marketplace on Solana. We have 0x, DYDX, Kyber, and many, many others that have gone through our program. We've supported over 200 founders and teams globally. And we have a team of 20 that has expertise in many areas of crypto to help support our founders. We take about 20 to 25 startups per batch twice a year. And the goal is to make sure that our founders are successful. And the way we do that is in 4 steps. 1 is helping you find the right idea. 2 is product validation, so helping you get and source your first 50 to 100 customers. 3 is helping you with the design, or what I call like the game theory design, which could be a token, it could be a game, it could be speculation. And the last is, kind of regulatory support and hiring and things like that. And obviously, there's a demo day where we help support our founders through, VC introductions and things of that nature. So it turns out the easiest way to build something, to find a great idea, is to figure out what are the things that your close network of friends or family are going through. What are some of the hurdles that they're going through, and how do you solve for that? And it turns out like the often ideas that you'll find are things that haven't been solved, but they seem very easy. I call this like low-hanging fruit. And the way you'd want to think about that is in 4 steps. 1 is, oftentimes, the people that are closest to you are the ones that are going to have areas of opportunities in terms of like onboarding. So an example of this is, how do you onboard the everyday user into crypto? 2 is, how do you think about the problems that they're seeing in the space? So an example of this I can give is, within crypto, it's very hard to find consumer applications that could solve real-world problems. So thinking about ways where you could leverage crypto as a way to enable some sort of problem that they're going through and being able to solve that. 3 is, from a game perspective, like, there's a lot of, Web 2.5, Web 3 games. But the core aspect of the games that people are building, what parts of that is crypto, and how do you enable that to be a way that you could drive more users to the platform? And the last but not least, the way I see this is taking what I think is, this is a very controversial topic, but people often say that speculation is actually a very bad thing for crypto. I think the counter, which is I think speculation's very good. It's just you have to embrace it in a way that could be net positive. And so some examples I can give you from this is Frontech has used speculation in a way that can enable some positive activity, which is like using speculation as a way to create more social activity, as an example. You saw a recent development with FriendPet, which is another like kind of speculative game where you feed a pet, you deposit some ETH, and there's this virtual cycle where the friend, as you feed the pet, then you get some points, and then et cetera, et cetera. I don't think they're breakout apps yet, but these are the early instantiation of products that can be built by using speculation. So I'll talk a bit more about that. The other mistake that I see that people make when they come into crypto is they usually do something that's part-time. And the problem with this is that it's very hard to find the right problems if you aren't full-time. And so here's like a perfect example. In DeFi Summer, for those that have participated in DeFi Summer, one of the biggest problems back then was the fact that onboarding was a mess, on-ramping, off-ramping was a mess. The ability to yield farm and all of the other things that come around it was a mess. And there's many products that solve this today, like Yearn, that kind of aggregates yield, liquidity, and helps find the best yield, etc. There's many things that have solved, but the only way you could actually find out of a problem is if you personally experience it. And the only way you could experience it is if you're full-time and you're actually using the products. 50% of the time I talk to founders that are trying to solve a problem, turns out they haven't even used DeFi, the product itself, or they haven't actually experienced the sector that they've been a part of. So what I say to the founders that are that's trying to solve a problem in their space, in their domain, is to start to use the products and start to experience what users go through. If you haven't been rugged yet, go get rugged. I mean, that's kind of the examples I'm giving you, because those are the only ways you'll be able to find the problems that the everyday user goes through. And this is kind of, coming to my next point, which is, I think every person that comes into crypto has a superpower. And what I mean by this is everyone has a special domain expertise. Whether you have a love for AI, whether you have a love for security, whether you have a love for consumer, all of these domain expertise is very important when it comes to crypto, because what crypto enables you to do is helps you build a product that's very differentiated. I think of crypto as a layer that sits on top of all of the verticals that exist today. And the idea is, how do you take the domain expertise that you have, or of special sectors that are out there, and using crypto as a way to build products that are very, very unique. So an example I can give you is Amir Halim, who's the founder of Helium. He founded a company that allows you to mine coins, and what you have to do is share your internet connection into a Wi-Fi connection. Then he started with hotspots. Now he's building a mobile network that sits on top. It turns out his experience goes further back, and it turns out it has a lot to do with networking infrastructure. And so he leverages his experience with networking infrastructure to build something that's very differentiated in crypto. And it turns out that is what is unique. If you look at the competitors for Helium, there aren't many. I'd probably say there's probably none. And so what I'm saying here is there's a unique DNA that every person has. Use it to your advantage, and don't shy away from it. Here's a list of how to not find winning ideas in crypto, and you hear about this quite often. People always tell you to talk to users. I think it's important to talk to users, but talking to users and leveraging taking their feedback accordingly is probably something that I wouldn't advise. So there was a funny meme that was being shared around Twitter a couple months ago. I don't know if you've seen it. If you haven't, you should look it up. But it was a meme of an iPhone that had a antenna. It had a VCR. It had a bunch of different gadgets that was attached to the iPhone. And the top of the meme, it says if Apple took advice from every customer that gave them feedback. It was a very weird looking product. But it tells you something, right? What it tells you is that customers oftentimes don't know what they want. And they will tell you things, and it may sound right to you at the offset, but it really turns out the real insight is solving a problem that they don't know yet exists. And that is kind of the special power of what I call what a founder should be really thinking about, which is what is the core root problem of this customer, and then validating that across all the other customers that give you this feedback. So going back to my point, which is when you talk to customers, try to figure out the root problem, but don't take their feedback literally. This is obviously a funny one, but I agree with this, which is oftentimes VCs write a lot of reports, but it turns out oftentimes it doesn't land the way it does because they aren't very close to the customers. And so a lot of the ideas you may see may sound great, but ultimately you're not going to find out about the problems that your customers are going to go through unless you talk to them. And so I would advise read the VC thesis papers, that's fine, but oftentimes that's not where you're going to find your next billion-dollar idea. You're going to find your next billion-dollar idea by either you yourself going through the problem, by going full-time and going through the problems that everyday users go through, or talking to customers and understanding like your close friends and family and seeing what problems that they're going through and being able to find a problem that, that you're able to solve. I also want to touch on how to find a co-founder. And the reason why I'm bringing this up in a hackathon is because oftentimes founders that find another co-founder, oftentimes it's at a hackathon. And I think when I think about hackathons, yes, we're all here to have fun, you know, hacking, and it's just a great way to network and meet people. But sometimes someone has a lightning in the bottle moment, and that lightning in the bottle moment turns out to be a billion-dollar idea. And I'll give you a couple examples. 2017, I was a judge at, or 2018, I was judge at ETH San Francisco, and Incidap team flew in from India, and I was one of their judges, and I actually judged them, and I gave them the thumbs up to get the reward to be a winner at ETH San Francisco. And I didn't think about it at the time, but it turned out to be a billion-dollar idea. Same thing happened with 1inch, and same thing happened with many, many other startups that came out of these ETH events. What I'm saying here is have fun, but also keep it back of your mind that, you know, if you're really here to build something big, you know, you should take some precautionary steps. And I want to go through just how to find a co-founder because I think it's important if you're looking for someone as you're building this out. How many of you have a co-founder already? How many of you do not have a co-founder yet? Okay. So this might be useful for you. And I think this will be useful for those that have a co-founder because there's some exercises that you guys can do to really test and see the validation of the bond, of the connection, and some of the other things I'll be talking about. I guess I have 5 more minutes, so I'm going to try to run through this. But what's important is like the why, what, and synergy. Why are you guys teaming up? You know, are you guys aligned in terms of how you see the future? What problems are you solving, and do you feel like you're aligned from that perspective? Can you trust each other? Do you feel like both of you have high agency? You know, how do you go through stress and the ability to be resilient when you're going through problems as a founder or co-founders? And it turns out like one of the biggest reasons why founders break up is because of stress and not being able to handle it. Second biggest reason is trust. And so there are ways to do fact patterns to figure out whether or not both are resilient. Oftentimes, Paul Graham says this, and many others say this, which is like having co-founders always a net positive. I tend to agree, but it doesn't mean that you can't start a company being a solo founder. But it'll help you if you want to grow fast and expand and things like that. But some of the reasons is like productivity, ideation, and being able to get moral support. And it turns out like stress, although it's heavy, being able to have someone that you can lean on is also very, very important. And it helps you in terms of being able to scale and grow fast. What I look for in co-founders is, are they domain experts? Who wants wealth? Who wants control? A perfect example of this is the Coinbase co-founders, Fred and Brian. Brian is the control, meaning that he wants to be the face of the company. He wants to have the direct control of how the company builds, accrues value, and where it's strategically going to go next. Fred was more on the wealth side. He goes, look, I'm here to build this company and make it generational, but I don't necessarily need to be the person that's under control. And it turns out control is also another big problem in terms of why founders break up, because both want control. So when you're looking for a co-founder, think about who wants to be control and who wants the wealth. And oftentimes, this is a good way to stress test and to see who can sit on one side. This is very obvious. Do they complement you? Obviously, you want to find people that you can work with that complement you, and making sure that there's very little overlap, because as a company, you're going to be wearing 4 to 5 different hats. And when you wear those hats, you want to make sure that they're wearing hats in different domains, so that way you can scale quickly. A good book I can recommend is Elad Gil's book on how to scale a company. And it talks about how to appropriately scale a company when you find product market fit. And this is a stress test I advise all co-founders to do when you're starting a company. It's very important. It takes 5 to 10 minutes. An example is, does anyone know Tensor, the NFT marketplace on Solana? No? Okay. They went through a program and they did this test when they found each other. And it's 5 minutes, 10 minutes long. They did this at a hackathon. So for those that are looking for a co-founder, I even probably would do this for people that already have a co-founder. Kind of gives you an alignment in terms of where each other are. Why do you want to start a startup? Where's your priority in your life? Are you control wealth oriented, which is something that is very important when you ask a co-founder this. What's important to you? Top 3 to 5 traits when you're hiring someone. Any ongoing commitments, and what happens if we make no money in 12 months? Actually, the last point is very important, which is like, what happens if you make no money in 12 months? This is when you know like if someone's all in or not. And you want people that are all in. And this is the rest of the questions here. You can take a picture of it if you'd like, but I think it's being streamed, so you could rewatch the stream to get the questions. So I'm going to end it here. And if you're looking for your next startup idea in crypto, we have a ton. If you visit our website, alliance.xyz/ideas. And if you, we are offering mentorship today, tomorrow, and Sunday. You could book time with me by scanning this QR code or with any of our expertise here at India. But scan this QR code, you can find time with me. I'd love to learn about what you're building and how I can help you and help you get to product market fit. Thank you so much.
Okay. Hey everyone, thank you for coming. Greatly appreciate the time. So I'm going to present today talking specifically about the base network and kind of how we can use account abstraction and paymasters to make the user experience better. So hey, I'm Carl Fluke. I'm a developer relations here at Base. The agenda today, I'm going to run through really quickly kind of what is the thesis of Base, what are we trying to build. I'm going to go over pretty quickly about 4337 account abstraction just so I can kind of level set for what is happening, what is validation, execution, how does a paymaster work. I'm going to run through, I may actually flip this order, I may do a hard hat deploy first to just show how you can use account abstraction in the deployment process. And then lastly end with a front end demo of how an end user experience looks when you're trying to use account abstraction with a paymaster. So why Base? That's always the first question we get is why did Coinbase decide to roll out a layer 2? So the big thesis that we have is that on-chain users continue to grow. We've seen Ethereum scale, and we see it continuing to scale. So as we have more of those users, we have more developers on-chain. And that's kind of a key thing that we want to keep growing is having developers actually building products to help consumers be successful on-chain. As we get more developers, then we actually have the bandwidth to start to tackle new use cases. So some examples that we have on Base here are like Friend.tech was a new social fi application that brought a ton of users on chain, and it was very user-friendly with the user onboarding. If you're ever in New York City, Blackbird is a restaurant loyalty. They offer a bunch of like coupons and loyalty programs for certain select restaurants. Parallel has brought a card game on chain. They're starting to innovate in that gaming space. Basepaint.xyz, if you've never seen them, it's kind of like Reddit Art Place to where it's pixel art. Every day they have pixel artists make a new image, and then you have one day to mint it. So very consumer friendly to where there's a lot of crypto behind the scenes, but it's usable. And then lastly, we have like our crypto, Stand with Crypto. So just bringing more advocacy and government things on chain. So most importantly, you can see this, I thought the internet wouldn't work. So you should see a blue line that has Ethereum essentially at capacity for the past 2 or 3 years. And then you'll see there should be a red line to where L2s are now like 5x the throughput of what L1 is, and we expect that to continue to grow. Okay, this one worked. So although that we've seen all this growth, we have more users on chain, we're still far from actually bringing the mass adoption. We're less than 10 million people, and there's 8 billion in the world. So we have a long way to go. And some of the key blockers that we see is cheap block space. So L1 was very expensive. I think we saw that after DeFi summer, people were much more questionable about like, can I spend $15 or $20 for a DAO vote? And some of that on-chain activity started to slow just due to the price. Wallet technology. So although like developers are very used to the current wallets, they're used to the Chrome extensions and the mobile apps, they're still very financially focused, and I think we have a long way to improve them. And lastly, identity. The blockchain is a permissionless, anonymous world, but once you start to add identity things, you can start to have primitives like credit. So there's definitely some interesting growth for identity on chain coming. Base has been live since August, so we're 4.5 months in now. Here's a long list of our, which is not loading also, sorry. There should be like 100 dots here with 8 categories. But we're continuing to grow. So that's the quick thesis of Base, is we want to bring more developers and more users on chain. Coinbase has 120 some million KYC'd retail users, and we're trying to slowly bring that audience and that capital on chain. So what is some fun things that Base has been trying to improve in the OP stack? The first was that we had a Canyon fork upgrade. This was 3 weeks ago, I believe, we deployed it to testnet. And this makes it so that it's fully equivalent to L1. You can use the newest versions of Solidity. It has a couple other upgrades to it. We moved our testnet to Spolia. So if you're not aware, Goerli testnet is going away at the end of January. So it's going to be a slow migration of all of our dev tools to Spolia. Some teams have started, but there's still a way to go. Something very relevant to this talk is that we've been experimenting with a paymaster. So how can Base as a protocol make a paymaster and help onboard apps and make them more usable? I'll go into depth as we get there. 2 big protocol upgrades that we're actively working on. Currently targeted for like early February is the Denkun Layer 1 Ethereum update, and this would make the first step of danksharding happening, which should reduce gas costs for L2s by 60 to 80%. And so everybody's looking forward to that as far as the L2 world. And then one more recently, EIP 7212, that makes it so passkeys could natively use their signatures on chain. Today, you kind of have to do some trickery of you can still use the passkey signature, but then you're kind of using a temporary key. And so we're looking at actually enshrining that into the base L2. Okay, so super quick run through of base there. Now let's talk about actual 4337 so we can level set so the demos make a little more sense. And my picture's still not loading. Okay, so the first most important part is you have user operations. I do have it now. So we have user operations here. Instead of transactions, you have these things called user ops. The main advantage of user operations is that with 4337, you can batch these and multi-call. So if you're doing DeFi things, in traditional world, you'd say, hey, I want to join this USDC, USDT pool. I have to approve USDC. I have to approve USDT. I then need to put what amount I want, and then I get some kind of C token, and I probably want to stake that for more rewards. So in an account abstraction world, you can actually do all 4 of those in one batch transaction, and the user approves something once. So that's kind of user ops, is they more or less replace transactions. It just means you can also do more than one at a time. Next is the bundler. There's quite a few bundlers out there, but the bundler is a resource out there that essentially collects all these user operations and they bundle them into transactions. So that's what makes multi-call possible, and that's also what can help reduce the gas cost of user operations. Next is the entry point. It's probably the least exciting thing. That is just where the bundler sends these user operations to, and that entry point knows how to validate or execute transactions. Then we have our contract account, so that's actually which smart contract wallet am I using. There's a lot of interesting stuff happening in that space now. There's another EIP out there called 6900 that's like standardized plugins. And some like Biconomy and Alchemy are starting to bring that third party or first party, which is interesting. I'll skip over aggregators, but then you have the paymaster. So the paymaster essentially allows the bundler to say, hey, this paymaster contract is actually going to pay for my gas for my user. And you can set kind of dynamic criteria of which users you want to pay gas for. And for the UX of this, that's really what I think matters the most for today. So to run through kind of that in more of like a, hey, what actually happens with these user ops? This did load, perfect. So we have this collection of user operations. They sit in this mempool. The bundler looks at that mempool. It bundles them. Then you see this loop for validation. So it looks through all those user ops and says, hey, can I actually execute this? And that's where the smart contract wallet can actually say, yes, I want to, or no. So if you want to put guardrails over like spending a certain amount per day, or you want to put custom validation logic, you can. After you validate all of them, then you look through actually executing them. So that's taking that call data and actually calling what you're trying to do. So that's approve token 1, approve token 2, or whatever your use case is specifically. And then lastly is that simplify gas. So you can have the paymaster sign that they want to pay for this user operation. And then I'll show code examples of kind of like how you can actually do that. Okay, so we're going to do a demo. I'm going to do this backwards. We're going to do the hard hat one first. So let me... How does this look? That's good enough. Okay, so in a traditional hard hat project, you'd probably see it very common that you would just say, hey, I want to deploy a contract, and you would just give it the name, and the system would be smart enough to actually look at what is the file that matches that in your contracts folder. So here's just an example. I'm deploying a smart contract. I'm logging what is its address. I'm storing a number in it, and then I'm just showing that I can also read that number. If you need an example and you want to deploy through smart contracts, this is kind of like the easy code example to start. So once I take that to the account abstraction world, this will show you how to do it with Alchemy's account kit. So this kind of runs through the setup of how do you actually go from a EOA to being a smart contract wallet. So I'm pulling out the paymaster part here. I'll end this section with that. The difference is since we have to pull that ABI and bytecode out of the compiled contract. So once you actually compile a contract, you get these artifacts. And the parts that actually deploy on chain that matter is this storage.json file. And so you want this ABI, which is your definition of saying, hey, what are my read methods? What are my write methods? And then equally importantly, you want what the bytecode that gets compiled. That's what actually gets sent over the transaction. So once I have those, I just am doing some setup of what chain, what addresses do I want to deploy. I'm loading my EOA. I'm creating that Alchemy provider. So this is very similar to just this is my RPC provider on what chain. And then this is the part that's account abstraction specific. So what this is doing is it's specifying my EOA as the owner. It's setting what is my entry point address, which I'm just using Alchemy's default. And then it's setting the factory address. So you can customize both the entry point and the factory. But this is just using the defaults. So what's interesting here is this smart contract wallet actually doesn't get deployed until it needs to be called. So it's called a counterfactual deployment. So you can find out the address of this account before it's used. Okay. So this is just showing that you can call get address before it's actually deployed. I'm setting up that paymaster middleware. I'll dive into that in a second. The main difference that you'll do for user ops versus transactions is you encode your call data as you'll either call encode deploy data or encode function data. And that just takes that ABI and bytecode. Since I'm a little tight on time, I'm going to skip through. I'm doing a create2 deployment here just so I can know what that smart contract address is, so I don't have to use an indexer to find out. I can find out counterfactually. And then I can use that smart contract wallet to call that deploy transaction. So it's coming from my smart contract address. I'm sending it to a deployment proxy, and then I'm just passing in that new contract. And then I'm finding out what that contract address is because I have create2. And then I'm doing the exact same stuff I did before. I'm saying, hey, I want to write a value 123 there. Just instead of me using a transaction like you would, I have to encode the data as a function data here. So I'm calling that function store, and I'm just giving it that new value. So high level, that's you can use hard hat to deploy smart contracts, to deploy new smart contracts. And the main advantage of that is I don't need a faucet anymore. I don't need to go to this permissioned situation. I know that this network has a paymaster out there that will pay for my deployments. So the nitty gritty of how our paymaster actually works is there's two things in the Alchemy SDK that I set up. I'm going to skip over dummy because it's kind of the same thing. But what this does is you get these properties of what was that user operation, and you have these extra values here. So you have gas limit, you have pre-verification gas, and you have your max priority fees. So all this is doing is it's taking all of those fees from your user op and it's sending it to this paymaster. It's just a simple REST call. I'm posting that data, and if it says that, hey, I will pay for this, I can save that to the user op, and then it's paid for. The bundler knows how to read that and pay for it. Okay, so that is hard hat really quick. I'm going to run out of time, so I will just quickly show. Ooh, my internet may not be good enough. I should be seeing my smart contract wallet here. Let me. Okay, yep, I'm going to run out of time. So I'm going to skip over the front end. Most importantly, you can find these examples. The hard hat example, which is probably the most useful for actually deploying, is just more or less a hard hat plugin that lets you do that paymaster for you. That front end example is just a very bare bones Alchemy example to mint an NFT, and that's showing you the front end experience of you can create a net new address, that doesn't have any gas, and you can do transactions. And then lastly, I net new added a Biconomy example that just shows how you can also set up that middleware in Biconomy, so that you have more choices than just Alchemy. And then, yeah. So that's my talk. I went super quick. Thanks for coming. If you have any questions, I'll be outside, and I'll be at the base booth all weekend. Thanks again.
Founder and CEO of Airstack. We have with us a number of members of the Airstack team here today. Depesh, our CTO. We actually have a number of our team also hacking here as well. So if you have any questions, there are lots of folks who can help you. Joseph here leads our DevRel. So we're going to go in and show you a little bit about Airstack now. So first of all, the way to think about Airstack is we enable you to build composability into your applications. So we enable you to very easily integrate all sorts of on-chain and related off-chain data into your applications. And unique to Airstack is that you can query both on-chain, off-chain, cross-chain, cross-DApp data into your applications with a single query and response all at once. We're especially strong in areas like social and identity, but we also enable you to get everything from token balances, token holders, NFTs, images, etc. The blockchains that we actually cover, can we show the diagram for a sec?
Yeah.
Yep. Yep. So this is a diagram of our APIs. The blockchains that we cover, first Ethereum, Polygon, and Base. We index every transaction on those blockchains within seconds of them finalizing. So if you are thinking about whether you want to use a testnet or not, we don't support testnets right now. We're querying the live data on the blockchain, so we encourage you to use Base or Polygon as your testnet or just as your net. And if you need Base, the Base team can provide you with the Base token on Base. They have a faucet here, and we can help you with Matic on Polygon, so can the Polygon team as well. So you shouldn't have to worry about needing any tokens in order to run your transactions. We provide indexing of all ERC-20, 721s, 1155s. As I said, you can get all token balances, token holders, NFTs. We also are the only indexer of 6551 token bound accounts. So you can get, if you're familiar with token bound accounts, it's NFTs that own other NFTs that own other NFTs, and so you can use Airstack to query both up and down that chain of ownership of 6551 accounts. It's a really exciting hot topic. If you want to work on 6551, reach out to our team. Joseph is an expert on it himself, so we're happy to help you with that. We also have a new feature that we're rolling out today with Base. In particular, it's called snapshots. You can actually get not just the current balances or current holders of a token, but you can get on any date or block stamp in the past as well. And so we can show you how to do that. And then, as I said, we're especially strong in domains, ENS, socials, identity, Farcaster Lens. We can get you everything about someone's Farcaster Lens, their profiles, their bios, their followers, and you can actually build common friends lists across the two of them as well. So we have a number of apps, for instance, we're building, we call the on-chain address book, which is just building out everyone that we know that you know across both Farcaster, Lens, people you've sent tokens to, and you can build like a friends list without even having to even integrate anything yourselves directly with Farcaster or Lens. POAPs, we index every POAP that's ever been issued, so you can build all sorts of insights into the events people have been to, and then we enable you to bring all this together across like integrated all together once. Lastly, so Airstack has a $10,000 bounty prize here at ETHIndia. We've also teamed up with XMTP, who's kicked in another 5K. So if you build something with Airstack and you include XMTP, the 3 Airstack projects that integrate XMTP in the best way are going to share that 5K. So there's a real opportunity here if you want to build with Airstack and XMTP to earn some serious prize money here at ETHIndia just by working with the two of us. Josef's going to show you how it works. He's going to show you how to run queries. Obviously, we can't show you everything in 20 minutes. I get the fun part. I'm going to show you the cheat codes. I'm going to show you how we use AI to enable you to write queries very quickly and to learn our APIs very quickly as well. So just take me to, not there, to the studio. Just take me to the studio. Just take me to the studio. Yeah. So when you go to the Airstack API Studio, you'll see on the left-hand side, these are all of our APIs. You can expand these, and within this, you can run all sorts of nested queries. What that means is you can start in one direction and head down this tree to another direction, What I'm going to show you really quick is the AI. So I'm just going to zoom in here for a second. I'm going to say, show all holders of, let's say, ETHCC6. So this was a conference in Paris. And so the 1,295 holders and their lens, Farcaster, ENS, and XMTP. And I'm going to have the AI build this query for me. And so what's great is it helps you actually see how the APIs are constructed. So here you see, it's actually a really complicated query. It's going to look at POOPs, which are on Gnosis chain, Lens, which is on Polygon, Farcasters on Optimism, and also off-chain and Farcaster hubs. ENS is a DApp on Ethereum, and then XMTP is actually off-chain data as to who has XMP or not. And so here you can see these responses are including answers from all of them. So here is one attendee of ETHCC6, that's his ENS, that is his lens. I'm saying his, could be hers. Farcaster and XMTP. And then you can also very easily add more data to this as well. So let's say I want to see blockchain, DApp slug, name slug. I want to have when it's registered, whether the ENS is primary. Just going to add a bunch of stuff here, what they actually paid for that ENS name. And I'm just going to run this again. And you see now we've enriched this with even more data that's all integrated in the same query and response. All right, Yost is going to show you how to build some queries. Let's go.
All right, thanks, Jason. So let's get started with really simple use cases. We just released like snapshots and base, so let's do that. So in here, if you see our API, we have a bunch of them. And definitely like AI is usually like the easiest way to get started. But in case like you need to build one from scratch, then for example, like go to the API right here, and it has certain formats in here. So for example, our API is going to have inputs and limits, and orders is for sorting, but it doesn't exist in here. But like for example, in here, we want to fetch the balance snapshot of Vitalik like right now. So then I just put owner in here, and with Airstack, essentially like you can even use like ENS, Lens, or Farcaster, so you don't even need to know like the 0x address because we have an internal identity API that resolve it. And for example, I want to also just get like for example the NFT. So in here I can specify that I want it to be like either ERC 721 or ERC 1155. So from there, balance snapshot essentially like fetching the token balances of Vitalik during a certain period of time, during that certain snapshots. But since I didn't define anything, it's gonna fetch me the latest one. So for example, like this, so start block number, start block timestamp, end block number, end block timestamp. And then I'm gonna show the token address and the token ID of the NFT. And then from here, I'm gonna show the token NFT metadata and also the images. So images right there. So metadata is also right here. So just run it really quickly. And it's essentially gonna fetch me the snapshot balances for Vitalik.eth. So it's a Wi-Fi, I think. So anyway, like I'm not sure what's wrong. Could be the Wi-Fi. So in this case, I can also like specify, for example, the time. So there, we have 3 different inputs for time. So there's date, timestamp, and also block number, depending on which one do you want to specify. So in this case, for example, I want to check Vitalik.eth NFT holdings last week. So that is like 2023 12/01. So 1st December. Oh. So essentially like that. And yeah, essentially this will return all the data, all the NFTs that Vitalik hold during that time, including like the resized images. So we have resized images right here, extra small, large, medium, and etc. The metadata, and many other details as well for the NFT right there. So on the other hand, other than balance snapshot, you can also get the reverse. For example, you want to get the holder snapshot. So in this case, we can get the NFT right here, and we want to fetch like the token holders during 1st December for this particular NFT, for example. So I'm gonna delete the holder in here, the owner, and I'm gonna add the token address, run it right there, and then it's gonna return me all the list of holders of this NFT during 1st December. So yeah, that's about it. So we provide a lot of this data, but of course, like we provide like other data as well, such as like social followings from Lens and Farcaster, POAPs as well, and essentially it all culminates into what we call like on-chain graph in here. So we have a documentation about it in here on how to do that, and essentially it fetches all the users' common POAP holders, common NFT holders on Ethereum, Polygon, and Base, social followings on Lens and Farcaster, and we have a demo in here, for example, on on Explore. So I'm gonna show you the on-chain graph of Vitalik.eth, and it's essentially gonna run me through all the users within his network that have commonalities based on on-chain data that I just mentioned. So yeah, that's about it. Yeah.
So in terms of getting started, you just need to go to Airstack XYZ and you can get an API key. When you go to Airstack, it'll ask you to connect a wallet. And with that wallet, if you have an ENS, a Lens, or a Farcaster, we provision a API key for you with 5 million free API credits. If you do not have a ENS, Lens, or Farcaster, come to see us. We have the ability to give you a Lens account here on the spot with no waiting time or anything. So you'll come to us, you'll get a Lens account, you'll then go to the website for Lens that's kind of claim Lens at XYZ, we'll walk you through it. And then when you go to Airstack, your 5 million credits will be there. And if you have any problems at all with the API key, you need help, just let us know. Beyond that, our team is here. We'd love to see you build amazing things. We've been to 7 ETH Global Hackathons this year, and what we've seen at each one is that the apps keep getting better and better and better. And one of the things that we love that you can do with Airstack is you can build an entire application in a weekend. So it's not about just building a POC. You can actually build a full-fledged application in a weekend, and we'd love to help you do so. So I'll take any questions if anyone has. We're happy to answer them. We have 7 minutes left. So any questions anyone has, we also can show anyone any additional queries or anything you'd like to learn about Airstack, just let us know. Anyone? Yes. Yes, I can hear you. Actually, there's a second mic. Why don't we give him the mic? Yeah, I couldn't hear you, so.
Can you hear? What kind of data can you query on the token-bound accounts, the 6551s? Can you see everything they own?
What did he say? Depesh, I can't hear it.
So the question is, what kind of data we can query on 655?
Yeah, come on up. Yeah. Yeah. Yeah, so the question is, what kind of data can we query with 6551 accounts? Joseph, do you want to answer that?
Yeah, for sure. So essentially, like you can get all the data for 6501, including like here in our docs, I can just show you really quickly because we have a section for 651 especially. So in this case, you can. Okay. So we have a bunch of use cases in here that we already cover. So essentially, you can go up and down the tree. If you know the NFT or in specific, like the token address and token ID, you can get the token bound accounts. Or if you know the token bound accounts, you can fetch like the NFT that controls it and eventually even the owner itself. And some stuff you can also build, for example, is also like token gating. ERC651 token gating. So this is like a more advanced use case built on top of our API. So the logic is basically the same as regular NFT gating. The difference is that just like instead of like user holding the NFT directly on their EOA wallet, sometimes they might have uh, a certain NFT within one of their 651 inside their 651 tree. So that's something to consider. So yeah.
So while we have the docs open, just point everyone, we have tons of guides for very specific use cases here, and I encourage you to look through it. It's everything from how do you build recommendation engines, resolving identities. One of the most common use cases for XMTP with Airstack is, so XMTP is a messaging protocol for one 0x address to message another 0x address, but I don't know Yosef's 0x address. I know his, let's say his Farcaster, and he doesn't know my 0x, he knows my ENS. We can message each other because with Airstack, the message gets through, so we resolve these addresses for XMTP. The inverse of recommendation engines, we also do a lot of things with XMTP with around spam filters. So this is something you might want to look at, is how do we use Airstack to help combat getting, basically keeping spam out of the inbox by knowing which messages are from people that either we know or they're likely to be a real person versus those that are unknown. And as you see, we have guides for things like Farcaster, Lens, POOPs, followers in common, balanced snapshots, which Joseph just showed, all sorts of different types of guides you can use here to help you get started. I definitely encourage you, take a look through the docs. There's a lot of things you can do with Airstack, and the docs are very thorough and very use case focused. Then we have time for one more question. Anyone else with a question? Anyone? All right, feel free to come up to us, and we're here to help. Thank you all very much. Have a great hack.
So a little bit about myself. So I am at libEVM. I'm currently an engineer at Mantle. So if you guys want to build any bounties on Mantle, let me know. Our booth is just outside. So yeah, today I want to talk about data analytics tools for Web3. There's a lot of flavors out there, but for more context about this talk, was the Paradigm. Paradigm had a Rust X Ethereum Day in San Francisco a couple months ago, and they talked something about the data endgame, where everything is fast, everything is cheap, everything is effortless, and you can get any kind of data in any format for any hardware. So I thought that was very intriguing, and so I kind of went on this little rabbit hole on how to better extract data. I know the standard today is using the graph, or for example, extracting data through JSON RPC calls, and those are fine, those are good. It's just an issue when you want to do analysis on data that is more than 1,000 blocks old. It takes time, it takes effort, and it is not effortless. What we want is to be able to transform, extract and transform data effortlessly we want to be able to extract and transform large chunks of data effortlessly. And so today, after going down the rabbit hole, I'll be telling you what I've learned, and hopefully you will learn something new as well. So tools introduced. So we got Ref, a Rust-based EVM node. We got Cairo, which is another tool from Paradigm, which is a Rust-based data extraction tool. And also we got Polars, which actually isn't a tool, but it's actually just a data frame library, which implements the Apache Arrow standard, and we'll get a little bit more onto that later. So to extract data, we first need a node, because that's where our data comes from. So here's some interesting statistics. To sync an archival node on Ref, it would take around 50 hours and take you roughly 1.92 terabytes. So this is a few months out, so I would say they're around 2 terabytes right now. On Aragon, it will take you around 5 days, or 2.2 terabytes. On Geth, it will take you 1+ months, and 14.5 terabytes. And Nethermind, it will take you 1+ months, and also around 14.5 terabytes. So I guess you might ask, like, why the discrepancies? Like, why does it take such a big delta to sync archival? When I say archival, I mean everything from block 0 all the way to the latest block. Why does it take 50 hours? In fact, there are snapshots for Ref right now, which reduces that down to 6. So if you spin up a fresh machine, you can actually get an archival node in less than 6 hours. And you might ask, like, why is there so much discrepancy? So the reason is because Ref actually uses a new kind of database technology, MDBX or something, developed by a Russian guy, single Russian guy, by the way, that is supposedly a lot more performance than Levels DB, which is what Geth and what I think Nethermind uses, which is why we can now store a archival node under 2 terabytes, which is really amazing. So a little bit of disclaimer here, Ref is actually heavily inspired by Aragon, and if you look through the source code, you can actually see a lot of its inspirations and where it comes from. And here are some acknowledgements. So Ref, blah, 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 has a lot of inspirations from Geth, Aragon, Akula, especially MDBX. But yeah, anyway, what the point I'm trying to make is that it is possible to run an archival Ethereum node on consumer laptops now. So back then, if you wanted to run a archival node of Geth or Aragon, that would take you 15 terabytes. But now with Ref and Aragon, it takes you maybe 3-4 terabytes, which is pushing it, but it's still very doable, And data is the new oil, right? We live in the information age, and like oil, data is valuable, but it's useless if it's unrefined. So we'll explore, now that we've explored how to extract the data and how to get your oil, we'll explore how to refine the oil. Anyway, archival nodes are basically the equivalent of modern-day oil reserves. And what's cool about data analysis is that everyone's on a level playing field, because no one's controlling some kind of secret data. The data is open out there for everyone to analyze and extrapolate. So here's what a standard refinement process could look like. You have your archival node, Ref, and then you would extract that out into local files or into your cloud buckets via some kind of format. Historically, this would be like a CSV. and you would maybe use something like ETH2CSV, which is a tool, to extract the data from your node into your local files and upload it to the cloud. And then you would kind of do some kind of transformation. Is the mouse working? Yep. Do some kind of transformation here via maybe something custom or maybe something standard, and then you would present the query results here. So there's ref, there's pocket and delta. If you don't know what that means, don't worry, we'll go through it later. And then there's your query results. So what I want to talk about today is these three things: Cairo, the local files, and Polis. So let's say hypothetically you got your ref node set up and you're ready to extract data. So what do? I would turn to Cairo. Cairo's again a tool from Paradigm, which is used to extract data into the Parquet format. And if you were like me 3 months ago and I didn't know what Parquet was, I went to ChatGPT and I kind of asked it to explain what it is in the context that I cared about. But basically, Parquet is just a data format. It can be like CSV, it can be a JSON. Parquet is just a more efficient way to store data and a more efficient way to store, read, and transform data. And it's also open source. There's a standard behind it. I think it's like Apache Arrows, if I'm not mistaken, and a lot of real-time time series data, especially financial data, uses the Apache Arrow standard, so it's battle-tested and scalable. Yeah, so this is just like a brief overview of the differences between CSV, JSON, Parquet, and Avro, which I've never heard before until I put this picture in. But yeah, so Parquet fulfills a lot of criteria. It's compressible, it's splittable, it supports complex data structures. For example, binary or even bytes. It supports strings. It supports lists of strings. But the only downside is that it's not human readable. So if you don't have any tooling to help you with, or if you're not familiar with computers, your typical R boys or your typical data scientists who can only read stuff from Excel, Parquet might be a bit cumbersome or tedious. But since we're all computer experts here, this shouldn't be an issue. So let's continue. And I notice you might have noticed that I've mentioned Rust many times. It sounds like I'm a fanboy, even though I am more of a Haskell fanboy. That's unrelated. Even though these tools are Rust related, if you are more inclined to use it in another library, for example Python, don't worry, there are Python libraries and wrappers available. This is my favorite image. The Python baby boy gets, gets his aid from the Rust soldier who's returned from the battlefield. Anyway, so this is how we can use Cairo. So this is the API for Cairo, and I think this is like a month or two outdated, and Cairo might have updated since. But using Cairo, you can extract a bunch of data sets, a predefined data sets, I will add, from your Ethereum node. So you could do things like you could hypothetically extract out logs from a certain range of blocks. So you would type Cairo logs into your terminal, -B, and you would put in like 16 mil to 17 mil blocks. So you extract out all these logs into like a Parquet file. Or if you're more inclined to extract out the block data, for example, the author of the block, the base fee of the block, the block number, the block hash, and so on. You can also do that through the blocks data set. And there are actually a lot more other data sets, predefined data sets that I will add, such as transactions, storage differences, where you can find out the slots, and slot differences, where you can find out the slot deltas for each contract, events, which is just logs, and bounds differences, which tells you the Ethereum bounds delta for each block. But anyway, this is how you would use Cairo dataset, and some other parameters. So let's say hypothetically that we've used Cairo and we've extracted out these datasets to our file. Like, how can we make sense of it? How can we use it? Well, how I would use it is I would read it in Python, because I find it a lot more easier to perform complex data transformations with. So how you could read it, is you could import Polis and read it using the library. But this is very tedious, right? You need to open up your Python interpreter, so that's like one command. You need to import the library, which is another command, and then you also need to type out PL, which is Polar's read packet, and enter the file name, which is also very tedious if you're not in the correct directory. So that's like 3 to 4 commands just to read a file. So tedious. So it's just not very, I would say, not very reasonable, not very practical for your average data scientist, Joe. But you know, luckily, we're all Linux experts, or to some extent, computer experts, and you know, you realize, hey, I could just alias this into some kind of command. And luckily for us, NotStorm at NotStorm from Twitter mentioned that, hey, why don't you just alias this command ppq, and then you know, now instead of typing out 4 commands, all you do is type out ppq and your file name, and then you can read the data frame like that in a jiffy. So yeah, this is like little things that actually make exploring the data a lot more effortless, which when exploring data is made more effortless, you will explore it more frequently, and then you will find a lot more relations or correlations. That's what I've personally found. Reduce the barrier of entry, reduce the friction required, and you will find yourself doing a lot more of these tasks. But anyway, so we have the data in a Pocket format, and now we want to do some kind of transformations to it. For those of you who are familiar with pandas, this syntax might be a little bit different, because I think like Pandas' API has kind of evolved over the years, but Polis is a pretty new one, and it has actually learned a lot from what Pandas would consider good. A lot of the API is very clean, very composable, and very consumer friendly. So this is an example of how, let's say I wanted to find which addresses would send out the most transactions in a given list, a given chunk of block. So I would group everything by the addresses, the to address, and I would aggregate things by the transaction hash. So pl.co transaction hash .explode just means I want to convert, when I group everything by this address, I want to group everything and accumulate it into a list. And after accumulating it into a list, as you can see here, in transaction hash is a list of binary data. I also want to count the number of times this transaction has been sent, has received, this address has received a transaction. And then we can just do a .count and we can alias it. So this is like 3 lines of code, and you've managed to figure out the most frequently sent addresses in Ethereum from a certain block range, which is pretty cool in my opinion, because if you were to do this in JSON RPC, where you have to manually query each block data, like doing 1,000 blocks would take you maybe 10 to 15 minutes. This took me less than like 10 milliseconds. So when you're doing like chunks of historical data, this is where this method really shines. You can do more complex analysis with Polis via its APIs, but you have to go in and kind of discover it for yourself. The API library is quite verbose and quite rich, so it might seem a bit intimidating, but I highly encourage you to start off with like a project to kind of check things out. For example, here we're checking out the intersection of addresses, like which addresses would send to other addresses, which is quite interesting if you're looking at from a forensics perspective, because you might want to say, okay, what addresses might send transactions at a similar time interval? You could definitely do this with a one-liner in Pocket, which is not this, by the way, but you could definitely do that through like some kind of between time interval thing. And this is done in chunks of data. And Polis has been shown to be able to transform over like a million rows in less than like a second. If you were to do that via JSON RPC, or if you do it via CSV, it could take a lot longer. But yeah, anyway, TLDR, Cairo, pretty easy to use, very, very open source and extendable. In fact, I've also extended it a little bit by writing out a custom data set that extracts out the pricing data. So in this case, for example, if I wanted to get the price of ETH BTC or ETH USDC or ETH DAI, I can write out like a custom contract to do so via the ETH call dataset. Yep. So we'll speak through this a little bit, but TLDR is that you can write arbitrary code for data retrieval without the contract deployment, and how you do that is by abusing the ETH call opcode. The ETH call JSON RPC code. So this works by returning data in the constructor, because usually you don't return data in the constructor in Solidity. You can't do that because why do you want to return data in the constructor? It's useless. But for our use case, where you just want to optimistically deploy a contract and get its return data, and extract the data into Polis, you can definitely do so. So we could create a contract like prices, which is a UN256, a list of numbers. We get the price for, say, the index, and then we encode it into this ABI encoding scheme and return the data. You have to go into some assembly fuck around, but that's the price you pay for wanting things to be clean, I suppose. But yeah, so this is how you would abuse the ETH call opcode, and I actually have a whole repository dedicated for that if you're interested. But yeah, you can just easily extract and organize data in an ad hoc manner. Maybe I'll call this JIT, just-in-time data. But yeah, TLDR, running a bit short on time. With Ref, we can now extract. We now have the raw data, and with Cairo, we can extract the raw data very efficiently and store them locally or in the cloud, and then we can use Polis to refine them. And so that's the structure that I found to be working really well for me. Thank you very much. Questions, if anyone has any, open to the audience. Nope, great, everyone's speechless. Thank you very much, appreciate your time. Oh yes.
Any links where you've
Oh, sorry, I can't hear you.
Hello? Am I audible now?
Yep.
No, any links where you've done any sort of data analysis using whatever you have explained right now? Is there like a repo where you could show some sort of analysis that you've done so far?
Oh, if I wanted to show, it's not open source, but I can show you a website I've built.
Okay.
Yeah. So, well, this is my website.
Just to get an idea, that's about it.
So this is my website. It's to analyze MEV data. The Wi-Fi is really slow, so don't judge me.
So this is done using the Red, Cryo, and Polars.
Correct. So I'm using Ref to extract the raw data. I'm using Ref to get the raw data. I'm using Cairo to extract the data, and I'm using Polis to transform it. And then so this is like the website. The data is quite rich. You can get very granular data. You can zoom in to specific time regions and get data. This is more like for MEV analytics. You get like a leaderboard if you want. But yeah, you get very granular data. I can show you like the API. Maybe like you get quite granular data. Like so, this is like builders data. If you want searches data, bundles would be probably better. Like this is the MEV bundles that we've identified in real time. So this is the current block. I would say that's like the latest block. And if we go to ETHIscan right now, we can actually see that. This was proposed 38 seconds ago, and we've managed to extract that out in almost real time, give or take, given the internet speed here. But you can see that the pipeline does work. I have a production app, so I'm not LARPing or cosplaying in any way. Yeah.
Thanks.
No worries. Yep. No other questions? Oh, yep. I think there's a question over there. We got 1 more minute, I think.
Is there any way we could get internal message call or internal ether transfers between smart contracts? Like, is there any way we could extract that?
Yes, you can. You can get it via balance diffs.
Okay.
So if you there's like a whole library for that, balance diffs, and then that basically does what you want. Yep, balance diffs. I'll zoom in a bit. Yep, this is what you want, balance diffs.
Okay. Yeah. Thank you.
Oh, sorry. Just to repeat. Okay, repeat the question. The question was, can you get internal transaction internal transactions Ethereum transfers, and you can do it via balance diffs.
Okay, thank you. Thank you, sir.
Yep. All right, thank you very much.
Hello, everybody. This presentation is Powering dApps with 1inch, and my name is Tanner, and I've been a contributor to 1inch for about 2.5 years now, working on governance teams, backend, and now currently developer relations. So today we're going to talk about the 3 1inch swap protocols that we have, and then we're going to talk about integrating these projects in these protocols into your project. So that's going to be talking about our APIs, our documentation, some example repos, as well as integration tips to make it easier for you to do. So brief summary about 1inch. We actually started at ETH Global at ETH New York in 2019. We didn't place very well in the actual rankings, but we still grew to become a pretty successful protocol with now almost 3 million users, over $300 billion of total volume processed through our contracts, and gave people access to over $55 billion of total available liquidity, as well as having 70% of the aggregation market share. So first, we're going to talk about what it means to swap with 1inch. We'll talk about our original aggregation protocol. We will then talk about the limit order protocol, and then our latest, which is 1inch Fusion. So today we are currently live on 12 different chains with our aggregator and our limit order protocol, and then with our latest 1inch Fusion, we're live on 9 of those 12 chains, and we will continue to expand to more chains as there's more liquidity and more need for swapping. So first off, the 1inch aggregator. This is what people who know who 1inch probably knows this part. It sources swap liquidity from all popular protocols. It combines these protocols to optimize the swap output for the user, and then it executes all the swaps in a single transaction. So if we just take a simple example, someone who is just trying to do a swap from USDC to DAI today on Ethereum, they're probably going to take their USDC and just go through Uniswap. This is fine. Uniswap is a very major player in the space. It's tried and true, and people don't have to worry too much about what's going to happen on the other side. They know they can trust it. But the UI that 1inch offers is very similar to Uniswap. It has the input token, the output token, and you just click one button and the transaction goes through and you get your output tokens. So quite similar. So let's just say the same user decides, okay, I'm going to go through and send my tokens to the 1inch router now. Then the 1inch platform will do some complex calculations and probably end up just sending the user through Uniswap again. But they're not going to do that in all cases, especially in bigger swaps specifically. It might split it out into multiple different dexes in the single transaction. So it might put some of that transaction through Dodo. It might convert some of the USDC into Tether using Curve, and then finally take that Tether, put it through SushiSwap, and come out to DAI. And it'll do whatever it needs to get the best output for the user. Some of you might be thinking, well, yeah, that's also going to increase gas costs by quite a bit, and that's true, but we factor that into our decision-making process as well. So if it takes more gas, but it gives you more tokens to offset that, then that's still the path we're going to take. So in the case where it does just go through Uniswap, and which is happens a lot of the time actually through our aggregator, you might be wondering, well, if it's just going to go through Uniswap in the end, shouldn't I just be going directly to the Uniswap router? Won't that actually save gas? And let's just compare those head to head. So if you do a swap through Uniswap with this specific token pair, it'll be about 205,000 gas. And if you do the exact same swap through 1inch, which then eventually goes through Uniswap, you'll actually only spend about 175,000 gas. So even in cases where it's an extremely simple swap that just goes through Uniswap, it will actually be cheaper through us because we've optimized the logic that goes skips the router and goes directly to their pools. Next, let's talk about 1inch limit order. So this supports makers and takers like a traditional order book. Takers pay the gas fees for the transaction, which means, gasless swapping from the user's perspective. And this removes MEV opportunities. And that's because you basically say, this is how many tokens I want to get for my swap. And there's really no room to do anything there because if it's less tokens than what you agreed upon when you place the order, the transaction's not going to go through. So again, UI looks very similar to a basic swap. There's just 2 new UI elements. One is the rate at which you actually want to swap those tokens for. You can just click set to market and make it essentially a market order, or you can go a little bit higher if you think there's an opportunity to make more money later by setting it at a higher price. And then there's also going to be the expiration time. So how long you actually want this order to last inside of our system. We default it to some small value. You can set it to forever if you want, but sometimes people don't want trades executing 6 months later that they totally forgot they placed. So it's totally up to you on that. Kind of a diagram to show what's going on behind the scenes when you place a limit order in our system. You, the maker, aka the user, would say, okay, I want to sell 50 USDC for 50.1 DAI. You will sign that transaction, essentially giving our router the permission to swap this USDC for you, and then that will go off into the 1inch API. The 1inch API will then feed that order to anybody who wants to listen to it. So they have the 50 USDC for the 50.1 DAI. And anybody who wants to listen for this and decide, you know, is this an order I'm interested in, they can kind of go through that on their own time. And eventually someone will say, yes, that is something that interests me, and they will execute it from their side. So they'll pay the gas, they'll execute the transaction, and you'll get the 50.1 DAI. Okay, on to 1inch Fusion. So the user submits a swap request with a signature, just like limit order. And this will kick off a Dutch auction that is created for the swap that the user is trying to do. And then the resolvers will asynchronously compete to fill this order during the Dutch auction. And again, users are protected from MEV by design here, because at each step along the way of this Dutch auction, there is a specific price at which the token needs to be swapped for. So there's no room for anything to be taken from the user's side during these swaps. So there were a lot of terms that were listed in that last slide, so let's kind of break them down. What is a Fusion Dutch auction? Or more generically, what is a Dutch auction? And you know, in a traditional auction, you start at a very low price, and over time, it goes higher and higher until eventually there's only one bidder left, and that's the price that the item is sold at. In a Dutch auction, the price actually starts at something quite high, and it works its way down until some bidder decides, okay, this is a good enough price for me to actually purchase. So a Fusion Dutch auction does the same thing, but with token prices. And then also, what is a resolver? These are entities in the Fusion system that are all watching these Dutch auctions while they occur, and they're the ones that are actually swapping all or part of the order as the Dutch auction slowly reduces the token price from their perspective. So here's a really simple diagram of what would happen in a Dutch auction. The y-axis is rate, and the x-axis is time. The top left point you see there is going to be the highest price that the token will be sold for from the user's perspective. So it'll be something slightly higher than market rate. And across the whole Fusion auction, it will slowly go lower until some minimum value, ideally when resolvers are happy to fill it and find their profits in the trade. So again, the UI is quite simple. You have the input and output tokens. You have the transaction cost, which is 0, which is really cool. It means you don't need any of the native gas token for whatever chain you're actually doing the swap on, which is going to be really good for mainstream adoption and ease of use for new users specifically. And then we have the preset, which is going to be like how long this Dutch auction will actually last. I think it still defaults to 3 minutes. And then it will give you the estimated output as well as the minimum output of the Dutch auction. So here's the UI, just kind of showing this thing actually happening. It's going to show you, you know, today in your history, there's USDC being swapped for DAI. It's going to show you how long the Dutch auction actually has left on it. In this case, it was 2 minutes and 49 seconds. And it's going to give you its estimate for what the actual return will be. In this case, it's going to be almost exactly as many tokens as you put in, because it's going from stable to stable. So again, let's look at what's going on with the diagram. So we have the user. They say, I would like to swap 50 USDC for DAI. The Fusion system will estimate something around 50 DAI coming back to them. The user will sign that transaction, and then it will go off into the 1inch API. The 1inch API will then start a Dutch auction. It'll say that, hey, this user is trying to sell 50 USDC. We expect there to be something around 50 DAI coming back, and this auction will last 3 minutes. And all of the resolvers in the system will now be monitoring this Dutch auction, and they'll be choosing to either fill it or not fill it as it progresses. So during most of the blocks after this auction starts, most people are going to be passing, but eventually the price will get to some point in which resolvers now are interested in filling this order, either part or all of it. And if they both try to fill the entire order, whoever is earlier in the transaction will get the priority, and the other person's transaction will fail. But that's not going to happen in all cases, because partial fills are allowed. So if the first resolver fills only a portion of the order, and the second resolver is also filling part of the order, there are many cases where they will both actually have their transaction succeed. So resolvers are competing with each other and also working together to fill the order as efficiently and fast as possible. So here is a graph of an actual swap that happened on our system for a massive amount of 3,700 Ether. And it's kind of a noisy graph, but the dotted line near the top that's perfectly flat, that's the market rate at the time this auction was started. And you'll see that the curved line with the dots across it is the actual rate at which the tokens are being sold for. So there are, I think, about 17 different points along this graph where resolvers jumped in and filled part of the auction. The first one happened around the 24-second mark, and the last one happened at the 4-minute and 48-second mark. So by the 5-minute mark, all 3,700 Ether had been swapped for USDT, and all slightly above market rate. Now, granted, it was only like $1 above market rate, but that's still pretty cool. That's a massive trade that happened all above market rate, which just wouldn't happen if you probably went through a normal pool. So you might be asking yourself, where do these resolvers get their liquidity? Like these entities, how are they actually fulfilling these swaps? And that is kind of the beauty of the system, is it doesn't really matter. All that matters is that the swaps are fulfilled at the specified rate. So the resolvers might be getting their liquidity from centralized exchanges. It might be through personal funds. It might just be using a DEX like 1inch behind the scenes to actually do the swap, or they might be doing something more sophisticated like cross-chain swapping. Okay, so we went over the aggregator, limit order, and fusion now kind of at a high level. Now let's ask the question, how do we actually use these in my project? And that's where Dev Portal comes in. So Dev Portal is the official hub for integrating 1inch into all of your projects. It provides things like the API keys to access our APIs, documentation for the swap APIs, as well as many more APIs, which we'll talk about briefly toward the end. It'll also give you examples as to how to do this. And yeah, so the link is portal.oneinch.dev. That's where you'll actually go to see all these things. And don't worry about writing any links down throughout this presentation. At the very end, there will be a link to everything we talk about today. So don't worry about catching anything mid-presentation. So if you go to the Dev Portal website, you're going to see a home page. You log in with Google or GitHub. From there, you're going to actually just choose what application name you want to give your project. It can be anything, really. It's just like an alias. In this case, I used test. And then after that, you'll hit your dashboard, which will have your API access key. It'll have your requests, as well as the rate of the requests that are going through. And if you go to the top, there'll be a docs page where you can actually see all of the information about the various APIs. So we click on docs. We see on the left now there's a bunch of different APIs on the left side. To keep things simple, we'll just jump in and we'll click on this swap API. That'll give us a drop down with a couple of the links, and we will go straight to the Swagger documentation. So we'll go down, click on Swagger, and we'll see all the different endpoints that this API has to offer. So we'll click on the top one, find the best quote to swap with 1inch router. And that will bring us to an interactive documentation page based off of our Swagger files. And so the middle is going to be what chain you want to be on, as well as all the query parameters to influence the output of the swap. And on the right will be code snippets for whatever language you actually want to do these calls in. So there's code snippets for Node, Python, curl, and Go currently. So let's go ahead and just fill out some of these parameters. We're going to fill in USDC and DAI, as well as a rate of 100 USDC. And we'll just click on the Try It button right inside of the UI. And we get our response. Lots of decimals because it's DAI, but that's roughly 100 DAI coming out on the other side. Now, also something that's really cool is as you fill out these query parameters, the code snippets update themselves too. So in this case, we now have a fully functioning call to our REST API using Node.js. So I'm just going to take that code snippet and I'm going to copy it into WebStorm over here so we can run it locally. Copy and paste that here, and then add one little bit of extra code to actually make the function call itself. And when we run that, we'll see at the bottom it's this exact same output. Well, almost the exact same output, but we see that the function works. Not much needed on our side besides actually writing the code to call it. Now, you can do this with all of our APIs. Just go through the documentation, use the REST endpoints, fill out the queries. But Fusion is pretty complex, so we made an SDK on top of it to abstract that by one layer. So here's the link to the Fusion SDK. And it is written in TypeScript, and it simplifies interactions like I just mentioned. If you go to that link and you check out the README, there will be examples of how to use the various function calls and try to make it as simple as possible for you there. And we additionally have an actual example repo that uses the SDK. So if you're using the SDK and it kind of is causing some struggles, there's actually one that we made that just writes a concrete swap from token A to token B, and you can check it out that way. So this is the link to that one. Like I just mentioned, it's a simplified version of a use case for the Fusion SDK. And again, this is probably best used as a reference because it's hard-coded everything. So it's not really meant to just be parameterized. Just take a look at it, copy it if you need to, or just use it as a reference while you're using the Fusion SDK. Some important notes about the 1-inch API requests themselves, which can hang people up, is if you're using our aggregator, you can't do it exclusively within a smart contract call. You actually always need to be making a REST call to our API first to get the call data. And the reason for that is the way our aggregator works is it's doing a lot of off-chain computations, like actually a pretty insane amount of off-chain computations, because it needs to look at all liquidity sources that we track on the chain, and then it needs to use your specific input amount to find the correct output amount. So all of this obviously can't be done on chain. So this is a step that is required no matter what kind of swap you're doing through our platform on the aggregator. So kind of a diagram to kind of show that happening. Let's say you have some Node.js backend that's trying to do some sort of scripted swap behind the scenes, and you have your smart contract, and somewhere inside of your smart contract, you want to make a call to the 1-inch API or the 1-inch router to do a swap, and it looks something along the flow like this. This will fail, or you probably won't even get this far, but visually this is what the failure would look like. What you actually want to do is your backend needs to make a call first to the 1-inch API with the token input, token output, and the amount. That will get you the call data you need, and then you can pass that into your smart contract, which will eventually make the call to the 1-inch router. Complexities also increase by one step if you're going to be doing things from your UI. These need to go through a proxy. If you try to do it without a proxy, you're going to run into content security policy issues as well as CORS issues. So this means using something like Lambda for your proxy, or even a simple Node.js server that you just run locally next to your project while you're trying to do a proof of concept. We'll go through, we'll reference a simple Node.js program that I wrote to make that easy as well. So let's say you have some front end, you try to make your first request to the 1-inch API to get the call data for your swap, and this is where that failure would occur. So what you actually need to do is have your front end first call out to a proxy layer. That proxy layer will then make the call to the 1-inch API, and then you can send that information in to your smart contracts. Here's the link to the simple proxy that will help you just kind of, proof of concept, easy to get through. All you do is just pass it the endpoint that you're trying to talk to, and it will do the rest of the work behind the scenes. Simple proxy. And then again, this one also has a very simple README. It's really hard to mess up, so don't be scared. Just jump in and give it a try. And then lastly, the dev portal has a lot more access to APIs than just our swapping platform. We have things like spot price information, token information, balances API. We just launched our portfolio API as well. So there's a lot more there that can help you a lot in your projects to just simplify the bootstrapping process, so you don't have to do things yourself, or you don't have to jump around and use a lot of third-party providers that all come together to make your project. So dev portal is a great place to start, and then it also gives you great access to a really powerful aggregator in the system, or a swapping tool too. So yeah, that's everything for me. Thank you guys. And here is the link. QR code that will give you links to everything I talked about today. So that means dev portal, Fusion SDK, an example repo using the Fusion SDK, and then a really simple basic local proxy. So use these to build whatever you're going to build now or during the hackathon. And yeah, come by our booth if you guys have questions, and we'll help you with any technical questions that you have. Yeah, thanks. Oh, yeah, any questions? Yeah. Oh, I guess it wasn't a question. Cool.
Sure. So one thing you said many times was, am I audible?
Speak up just a little bit. I can't hear you.
Okay. Am I audible now?
Now I can hear you. Yeah.
Okay. So one term that I heard many times was resolver fills something. What is the meaning of this fills? A resolver is filling something.
Just fills the order. So they're doing either part or all of the swap that the user
yeah, I just want to know what is the meaning of filling an order.
So orders in this case would be token like a token A to token B. So a user's order would be I'm trying to swap USDC for DAI, some amount of USDC for DAI. And then when I was saying filling, it's like the resolver is saying, okay, I'm going to give you 25 DAI for 25 USDC from that order. So they're essentially just doing what AMMs have been doing up to this point, but in a more sophisticated way.
Understood.
They're the counterparty.
Understood. Thank you.
Yeah. All right, any other questions?
Is there anywhere I can get help, like after hours, if no one's at the booth?
Oh, yeah. We have a Discord available, and we have really smart people in the Discord, too, that can help you guys if we are no longer at the booth. All right, cool. All right, thanks, guys.
Hey, hello. Welcome, everybody. Thank you. So my name's Matt Hamilton. I'm a developer advocate at Protocol Labs. We are generally known for Filecoin, IPFS, a number of other technologies like libp2p, it's a networking protocol that's used in about a dozen different blockchain systems. So today I'm going to be talking about building projects kind of unique to the Filecoin ecosystem. So Filecoin has in the context of this hackathon here, Filecoin has a virtual machine, FVM, and FEVM that allows you to deploy Solidity contracts to Filecoin. Well, that's all great. That's just like any other EVM type blockchain. But what sort of interesting things can you do related to Filecoin, related to storage? And I'm also going to talk about some exciting upcoming tech that we're demoing here as well and previewing. Very much cutting edge stuff, but there's some really interesting stuff there that people might want to take on. So I'm going to quickly go through, just to set the scene here, some of the challenge statements. We can go over this again later, so I'm going to go through this relatively quickly now. We've broken it into a number of categories. So we've got programmatic storage. If anybody was in the talk by our friends from Lighthouse, Lighthouse is a storage aggregator that stores data onto IPFS and Filecoin. They covered some ideas with regards to programmatic storage as well. So things to do with automatic renewal and repair of data. We've got a service called RAS, which is a set of contracts that allow you to indicate that you would like a particular piece of data to be automatically renewed at the end of its storage lifetime on Filecoin. Data DAOs, so decentralized autonomous organizations in which they manage data. So this might be you have something in which you want to upload some data and have it collectively managed by a group of people. Maybe you even have something like an endowment fund that generates passive income through some other mechanism within Web3 and uses that income to then pay for the future storage of data on Filecoin. State storage integration. This is a kind of concept that we're showing here that allows you to, on FVM or any other blockchain actually, pull data in from things like IPFS and Filecoin. So it's more of a sort of a pattern and an interface to use, but you can use it very flexibly on multiple different blockchains to pull data into smart contracts. DeFi, so one of the unique things about FVM and about Filecoin is a huge network with a large number of storage providers on the network. The network is a total of about, I think it's about 11 exabytes of data at the moment. It's about 1% of the entire data center storage capacity worldwide. And that is a large amount of infrastructure there. You may have heard the phrase DPIN, decentralized physical infrastructure. Well, Filecoin is probably one of the largest examples of DPIN around. It's also, coincidentally, one of the largest implementations of zero-knowledge proofs, something that some people might not realize, that Filecoin uses zero-knowledge proofs, has done for about the past 3 years, and it's probably the largest production implementation of zero-knowledge proofs out there at the moment. But yeah, with all of that infrastructure out there and all of that effectively equity within the infrastructure, it gives rise to some really interesting DeFi models, because these storage providers have storage deals that they may be getting paid for, and they might want to borrow the Filecoin token fill in order to pay collateral for those storage deals. Conversely, they might want to, either lend against future revenue that they might have, or they might want to borrow as well from that. And then we get on to new tech breakthroughs. This is the bit that gets really quite exciting. Be warning, there be dragons. This is really cutting edge stuff here that we're working on. Anybody who was in Bangalore will know this, because I went to demo some of it. But we have got the Mycelium testnet up and running now, so you can have a go with it. So there's a couple of new things around IPC, which is Interplanetary Consensus. So IPC allows you, I'm going to cover this in a little more detail, to have subnets on the network. So individual networks that come off of the main network. So think of it like layer 2, but in a recursive fashion. Layer 2, 3, 4, 5, you can have multiple subnets there. So like I said, I'm going to cover that in a bit. But this gives the ability to be more flexible. So you could create a subnet in which you replace the virtual machine runtime on that subnet. So you can replace FVM that we have on there, or rather FEVM, which is the Ethereum layer on top of the Filecoin virtual machine, with another virtual machine. So something like Moves VM or Poker VM, Solana VM, for example, you could implement on top of that. Now, it's a lot to do within 36 hours, but I know that some people that are up for a challenge, it would certainly be interesting to see people kind of have an attempt at that. And with these new tech breakthroughs, we're going to be a little more lenient on the judging on them because we know that these are real stretch goals. So people that make a a valiant attempt, even if you don't necessarily cross the finishing line with what you're doing, but you show some very significant progress and learning, then we'd be very interested in that. So new runtimes, also large-scale applications. So using things like blockchain for gaming. So for example, things like turn-based games. You could make something like a simple, like a board game, for example, and you could use a blockchain for that. You could use a subnet for that, because we're reducing the block time right the way down to a couple of seconds, and so you could actually use that as part of storage and part of the logic system of a game. So onto a little bit of background. So that's the bounties kind of gone through, and we'll go through those again later. But Protocol Labs, like I said, you know us mainly from probably the three biggest things we're known for are IPFS, Filecoin, and libp2p. People that use any of the technology that we have developed there up here are eligible for bounties, including some of the storage aggregators like NFT Storage and Lighthouse, and the CDN that we have, Saturn, that is a content distribution network for Web3 as well. So bonus projects for building out unique ideas. Please don't just go and store a little bit of data on IPFS and come to us. It needs to be something more than just IPFS, right? If you're using one of the storage aggregators, like I said, Lighthouse NFT Storage, that's fine. We'd really love to see something more exciting than just storing a little bit of data on IPFS. It's one of those kind of almost unfortunate paradoxes that we have. IPFS is so simple to use, which is great, but on the other hand, it means that sometimes we can get some projects that are not as exciting as they could be because one line of code to store something in IPFS, we'd like to see somebody stretching things a little bit further if they can do. So the Filecoin master plan, build the world's largest decentralized storage network. We've done that, and that's continuing to grow even more. Onboard and safeguard humanity's data. We have a number of projects that are pulling in large-scale data from public archives, research organizations, that kind of stuff, to be stored on the network. We're also looking for people within the Web3 ecosystem to be using Filecoin as well for storing data. And then the next stage is bringing compute to the data. So you can kind of think of this as a bit of an evolution. Where we're talking layers here, we're not talking layers quite in terms of layers like as in blockchain layers, but more as in sort of conceptual layers. So if you think about IPFS and libp2p as being kind of the ground layer on which a lot of these technologies are built, and then we've got things like layer 0, the Filecoin blockchain itself, and then layer 1, the FVM, the Filecoin virtual machine, and that allows you to do compute over state of data. So this is just something to be clear about. With Filecoin, the actual data itself is not stored on a blockchain. There's no way we could be storing 10 exabytes of data on a blockchain and getting consensus on that globally. So the data itself is stored off-chain. What is stored on Filecoin is the metadata, the accounting data, and the proof that that data is actually stored and is safe. So FVM allows you to do computation around that and logic around that state. So how long is something stored for? Is it still valid? Can I instigate a renewal of that data or replication of that data? That's all kind of things around FVM. And also, like I mentioned, DeFi, things like loans, for example. How much storage capacity has this storage provider got? And could I use that as collateral for a loan? And then we get into like layer 2, which is IPC, the Interplanetary Consensus, and that allows then really performant dApps with chain scalability. Scaling both horizontally, so you can create multiple subnets and scale horizontally, so that might be regional scaling, or it might be scaling based upon a particular application, for example, or use case, or vertical scalability. Because with IPC, you can actually chain blockchains and have layer 2, layer 3, layer 4, etc. going down. I'll talk a bit more about that in a bit. So I mentioned FVM, on-chain programmability. I mentioned about how FEM manipulates and allows you to interrogate the metadata around the storage deals on Filecoin. It allows programmatic storage with smart contracts like RAS. So if you saw Lighthouse's talk earlier, they showed an example of using RAS, which stands for Replication as a Service, or Renew or Repair as a Service. And they demonstrated using a smart contract to actually instigate that logic around renewing storage there. And the FEM, the FEVM layer on top is fully EVM compatible, so you can use MetaMask, Remix, all your standard tools, Hard Hat to work with it. So here's a developer resource for programmatic storage. If people want to grab that QR code there. So that will take you through to, I think that takes you through to some documentation on Lighthouse on how to use RAS with it. We also have a renewal as a service starter kit as well within the Filecoin project on GitHub. So the RAS starter kit that can help there as well. Then another example is data DAOs. Now I'm going to actually, yeah, I think I've got time, do hopefully a very quick demo of a data DAO. So like I said, a data DAO is a decentralized autonomous organization that can deal with the management of that data. So what we've got is an example where we're using a governor smart contract. That's a standard contract from the Open Zeppelin project that's used by many DAO projects. And what we're going to do with that governor contract is we're going to submit a proposal. And that proposal is to store what's called a CID, so a content identifier, on the Filecoin network. So this is something that's already stored on IPFS somewhere, and we want to store it on the Filecoin network for longer-term archival, verifiable storage on there. So we're going to make a proposal to this governor contract. Now, this governor contract, for the purposes of this demo, is only going to require one vote for this to be approved, and the voting period is only going to be 3 minutes, right? Typically, you'd have something longer and more in depth. And once that's approved, you can then execute that proposal. And executing that proposal will then cause it to be sent to Lighthouse's RAS contract and then stored via Lighthouse onto Filecoin. So I can give you like a little quick demo of this. I've just deployed these. You can see here with Hard Hat, I've just deployed these contracts. And so the next thing I need to do, if we look at the documentation here for the Data DAO kit, it gives us an example here. So I am going to propose a particular CID to be stored on the network. So if I clear that, put that up there. So yarn hard hat propose. I give it the CID and I give it a reason. Hello, Bengaluru. So I'm going to do that. That is going to propose that to the network. That's going to take a little while to actually execute on the Filecoin network. So in the interest of time, what I'm going to do is I'm going to skip forward a few slides, talk about a few more things, and I'll pop back to this demo kind of as we're going along, okay? So this is making a proposal. Once we've made a proposal, we're going to vote on it. Actually, maybe what I'll do is I'll just wait until this goes through, and I'll execute the vote, and then we can move on. So going back here, we can see there's a vote command. And in the vote command, we need the proposal ID. That proposal ID is going to come out of this proposal command. So we'll see in a minute. Once this finishes executing, we'll get a proposal ID, and we'll feed that into the next command. Like I said, this is all in the Data DAO starter kit. The QR code is there if anybody wants to grab that to follow along with this. This will be a good basis for if you want to try and do some things here regarding managing data. I'll talk to some people that are interested in things like refi, some interesting examples with regards to storing data for conservation purposes, for example, that might be interesting here. So that's finished. It's come back with a proposal ID. So if I just paste in this vote command, I'm just going to replace the proposal ID there with the one it's come back with. And that's going to now vote. So we have 3 minutes to vote. So this vote should go through within 3 minutes. And after 3 minutes, I can then execute the proposal. So whilst that's waiting, I'm just going to continue on here. I'll talk about the system state storage. I mentioned this right at the start with the bounties. So state storage, again, there's a QR code that will take you there to a state storage starter kit that we have. And this is a mechanism by which you can request that some data from a CID be loaded into your smart contract. Now, obviously, bear in mind you don't want to load huge amounts of data into a smart contract because you've only got limited processing within Solidity and costs, gas fees, memory usage, etc. Again, you don't want to be loading too much. But if you have a small CID that is under a single chunk size, I can't remember exactly what a chunk size is on IPFS, a few kilobytes, I think, you can request that that be loaded in. So what happens is you have a smart contract with a method called request blob load, and you pass in the CID a reward that you want to pay, and you could implement a reward function within this as well on a timeout, and that emits an event that is listened to by a little daemon that you run. If you look in the starter kit, there's a little JavaScript daemon that you run that connects to the network and listens for that. And when it gets that back, it fetches that CID from IPFS. You have to run a local copy of what's called IPFS desktop in the example we've given. Obviously, you can extend that to do whatever you want to do. But if you've got local copy of IPFS desktop, it'll communicate with that, fetch that CID, and then call this deliver blob method and pass in this thing called a correlation ID that it gets and the actual payload of that CID. And it will validate that that data is valid, because a content identifier, if you're not aware, within IPFS and Filecoin, data is referenced by a content identifier. That is, in simple terms, a hash of the data. So if you have the content identifier, if you have its address, you can verify that the data is in fact intact, and the data that you requested is actually the valid data, because you can actually take a hash of that data, compute the CID, and see if that matches what you requested. So you can do that and get the data in, and then you could do some processing on that within Solidity. Let's see how our vote is going. So our vote's gone. I'm going to now do I'm going to execute, and the execute command looks very much like the propose command. And so hopefully our 3 minutes is up now. The voting period is over. If it hasn't, I'll get an error here telling me that voting period is not quite over. In this case, it looks like it is. It's going through. So this is now going to execute that command and send that CID off to Lighthouse to now go and get stored. And I don't know if we'll have time to see it, but in a bit we can probably check the Block Explorer, and we should be able to see that having gone through. So, state store I mentioned. Oh yeah, this is just a diagram of kind of outlaying what I mentioned here. You have a client DApp, so looking at the yellow boxes along the top, a client DApp, you have what's called the data management smart contract, that's included in the starter kit. You have a data relay daemon, again, that's included in the starter kit. That just fetches locally from a local IPFS node and fetches that data from there. So you see kind of going through the top here, we go from the client to the smart contract to data relay daemon to IPFS, and then the data comes back basically the opposite direction back through there. So, but in that starter kit, there's examples there you can basically play with. So on to some more exciting stuff, interplanetary consensus. So interplanetary consensus is unlocking basically web scale, or planetary scale performance for Web3 apps. And like I said, both horizontal and vertical scalability. There's a couple of QR codes here. The top one will take you to an IPC Docker image that's made by the developer experience team, the DX team that I'm a part of. That will allow you to get started fairly quickly using just Docker. Be aware it will download a fair bit under Docker. And then there's the IPC docs, that's the next QR code down. They'll take you to the documentation about IPC as well. There's a lot more information there. We've got here, so this is the docs here. That QR code will take you to within the docs. We've got a couple of quick starts that allow you to do things like deploy a smart contract to IPC. So we have a public testnet called Mycelium, and you can just configure MetaMask. There's instructions there how to configure MetaMask to point to Mycelium, and you can deploy to that just like you would do any other layer 2 or layer 1 network. But where it gets really exciting is you can deploy your own subnets. So you may be able to see on the right-hand side here, we have a number of subnets that kind of come off of the root network. Each subnet is its own entire complete blockchain. So in IPC, it uses Tendermint and Comet BFT for the consensus protocol. And you have a number of nodes running there. They are a complete working blockchain in and of themselves, right? We actually have in that DX container, you can actually run a local, what's called a test node yourself that is an entire subnet that's not even anchored to any other network. So if you want to have a play around with something locally really quick, you can deploy a test node and interact with that. But you can anchor the subnet up to a parent network. So in this case, you could anchor it up to Filecoin, but actually it's you could anchor it to any EVM network. I was talking to somebody from Polygon who was interested in anchoring it to Polygon. I said, yeah, sure, give it a try. So that should work. Periodically, the subnet then checkpoints its chain state up to the parent subnets, and that's how you get effectively the long-term security there from the parent chain. So you can use IPC to shard applications or shard a network into either networks, subnetworks per application, or potentially per geographic region, for example, on there. So here we go. Here's an example here. We've got like main nets, layer 2 networks, layer 1 networks at the top, and then going down to things like you could have a gaming subnet or a database subnet, and then maybe different games, and then, for example, regional subnets underneath there as well. The ultimate goal that we're aiming for with this is that these IPC subnets will be so lightweight, you'll actually be able to run a subnet node within your browser. It's not here yet. That's the direction we're going, though. But that'll give you a bit of an example as to what might be possible. For example, you could have a game in which the main long-term game state, imagine things like the high score table, for example, are stored in a regular subnet off of IPC. Maybe where we have, one of these like game A, B, or C along here. One of those could be that game, right? Then when a group of us go into the game lobby and start a game, maybe a dozen of us start some kind of interactive game with each other, then each of our browsers could spin up an IPC node to create a subnet, an ephemeral subnet that just lasts for the duration of that game. Now that game subnet could be responsible for just things like our score within the game we are playing, enforcing the rules and the consensus within the game we are playing, making sure that one of us is not cheating, making sure that in-game currency or items can be passed between us in a secure and fair manner. Once we get to the end of the game, somebody's the winner, say, their score could then be propagated up to the higher subnet that is the longer running subnet, and the subnet that's within our browsers, the ephemeral subnet that was just for that game, can be discarded. Right? We don't need that anymore. That was just around to ensure that the game play was fair for the duration of the game. But the actual long-term artifacts of that, like the high score, for example, could be passed up to a longer running chain. So that's a kind of an example as to where this kind of all fits in together. Thank you. So just to reiterate, going back to the challenge statements, I'm just going to bring up again the new tech breakthroughs one, because like I said, we've got a number of challenge statements here. Most of which, if you've been to any of the other ETH Global hackathons or ETH Online hackathons, may be familiar to you. But we've got some new stuff. Like I said, there be dragons. This is stretch goals. It's a lot to potentially do within 36 hours. But if somebody wants a challenge, then by all means, take it on. We can look at things like I said, new runtimes, larger scale applications, running games, that kind of thing on there would be really interesting to see. So that's everything. Thank you very much. And if anybody has any further questions, I'll be just down and probably just at the entrance of this room here. Myself and Juan Benet, founder of Protocol Labs, who's just sat here in the front, will be just stood outside here if people have any specific questions. We've also got the Filecoin booth, which is directly opposite here on the far wall. So you can come and chat to us, come get some swag as well. Okay, thanks very much.
This. Okay, let's start. Oops. Yeah, full screen. Hello, welcome everyone. This is the first time I'm doing this kind of a communication. Seems interesting and funny, but it's nice. It's nice. Can you hear me? Yeah. All right. Great. So let's start. Have you Octo? We started Octo and building Octo as a product. It's mainly a wallet product, and we started developing this around a year back. And in last 1 year, roughly 50 engineers have put in their hard work to make this happen. And right now we are India's leading wallet, and we are expanding globally at a rapid pace. Octo, CoinDCX is India's largest centralized exchange, and Octo is a part of the organization, the CoinDCX. And yesterday we announced Octo's wallet SDK, which and put it in the alpha phase. And today we are doing a hackathon, so a lot of pressure on the developers. It's it's very tight schedule. The developers have been awake since last few nights, but it's going great. So let me just cover. Let me just cover what are the current challenges in the wallet ecosystem and how are we addressing them. The wallet, of course, is a gateway to the entire blockchain ecosystem. The CeFi exchanges, on the one hand, give you exposure to the asset classes and let people invest in crypto. But if you want to use blockchain-based applications, then the only way is to have a wallet and access the smart contracts via the wallets. Now, it's also a fact that most of the customers access internet with their mobile phones and on the mobile applications, mobile apps. So blockchain-based applications also will be accessed via the mobile apps. Currently, most of the dApps we see are on the web browser, but that's not how most of the people, billions of people, whom the industry, as an industry, we are going to onboard. That's not how they will use it. Most of the blockchain applications will be used via mobile apps. That's the future. That is how we have seen the evolution of internet itself. First, it started with mobile, started with web browsers, but now it's all mobile apps. So Octo's mission is also to enable that, adoption of blockchain on the mobile apps. So with that in mind, when you develop a blockchain-based dApp on the mobile app, it is currently, with the current technology stack, it's almost impossible, because you have to go via the connect wallet route. Any dApp that I am using, I always, if I have MetaMask as a wallet, I have to go and connect wallet, and then anytime I perform a transaction, it goes back to my MetaMask, and then I have to click on sign. First approve, and then sign. Then I'll go again back to my main application, and 50% of the time it just fails. So it's a huge bottleneck for the mass adoption. With Octo's wallet SDK, this goes away. You just add the SDK on the wallet, on the mobile app, and this signing, just becomes a click of a button right then and there within your application, and there is no hops involved. So that is a breakthrough which we have achieved using two technologies: account abstraction, with which we create session keys and that is how we deliver this value. And second is multi-party computation, which we use for the private key management and its security. So Octo's SDK is the way for mass adoption in India and otherwise. And most of the companies will end up using this kind of a product if they want to build on top of blockchain. Moving on. So I have covered all of these. Now, as a developer, if you are using an SDK, one of the important things is once the customer interacts with the SDK, once the customer interacts with the wallet, how is the customer funnel happening? As a company, if I'm adding any SDK in my app, I need to understand the customer behavior when the customers are interacting with that SDK. It's super important. For example, we added a payment gateway. Now customer goes on the payment gateway screen. Now, how many people dropped on the first screen of payment gateway? How many people dropped on the KYC screen? How many people were, completed the payment gateway? And all of these things as a company, if I'm adding any SDK into my app, I need to know all of these stats, So that's one of the problems that we have solved. If anyone integrates Octo's wallet SDK, then you have a complete visibility of how the customer is behaving when interacting with the Octo wallet. So that's and of course, and then there are a lot of things like quests and reward centers. So it's a package. I'll not go into details of everything, but this is one of the key highlights when it comes to customer experience. And for developers, currently it takes 2 months to add such a powerful wallet, on any mobile application. With Octo, we have tried that any mobile application can connect to blockchain and have a wallet within just a day. So it requires just one developer, and any company can become Web3, from Web2 to Web3 in a matter of just 1 day. That's a huge value proposition, and this alone it reduces the barrier, for the entire internet-based economy to start using the power of blockchain. And when you reduce this entry barrier, this becomes a very powerful thing. So that's what we have done for developers, and there are entire suite of products like cross-chain bridges, trading APIs, and so on and so forth. So I'll now hand over to Asad for going into some more technical details of how to implement the SDK within a mobile app. So thank you so much.
Thank you, Neeraj. This was basically our product in terms of overall what Octo SDK is going to give for developers and for the users. When we talk about the wallet, Octo wallet tech stack is briefly divided into multiple layers. One is a security layer, one is a wallet layer, and the one is an interaction layer. The interaction layer basically enables you to do all the interactions and abstracts out the details of cross-chain liquidity aggregation, bridging, paymaster, gasless, or any tokenomics interaction. Any interaction that happens on Octo SDK goes through a risk layer, which basically gives multi-factor authentication and custom validation in terms of smart contract wallets, so that we basically safeguard the user from any malicious activity. And as a wallet layer itself, which sits on tops of all non-EVM and EVM chains. The architecture is pretty simple. The dApps will be interacting with the Octo platform. We are giving Octo SDK in Android as of now. By tomorrow morning, we'll be also launching our web APIs as well. And internally, the platform interacts with the account abstraction wallet, to which the primary Octo wallet or the Octo app will be also interacting with. Let me just briefly go down into the nitty-gritties of the SDK itself. So we have a documentation available in docs.octo.tech. It gives you a basic starting guidelines of how you can start and integrate your wallet in less than 10 minutes. For any developer who is building on top of it, we have also given a sample application on our GitHub account as well, which is also mentioned on the documents itself. So to start off with, what you have to do is you have to basically integrate your Maven repos. This is interacting with our internal packages that we have built. The binaries we have hosted on GitHub, you can directly use our credentials that we have given, or you can even create your own access token using GitHub developer profiles, and it will now allow you to interact with our packages. The dependencies that you have to add 2 dependencies. One is a Flutter dependency on your Android app. The other one is a base Octo wallet directly. If your app is already using a Flutter activity, which is anything that Flutter app will open on top of your Android app, you can add that activity. You can skip this part. Otherwise, you can add this activity in your Android manifest, and it will basically make your wallet work. Now, when we talk about Octo Wallet itself, it is a bunch of classes that you have to use. The base class is Octo Wallet. You can initialize the Octo Wallet using your API key. In order for you to get the API key, there's a type form in the document, the docs. You can request API key in the docs, and we'll send it to you on mail or Discord. Once you have initialized your Octo Wallet, next you have to do is authenticate. So the first factor of authentication that we're using in Octo Wallet is Google Auth. So when your user will be using sign in with Google, they will be getting ID token in return. You can use that ID token, pass that ID token directly to authenticate. In our sample app, we have already given you an activity which enables you to directly use Google login. If you have your own version of Google login, you can directly use that, pass the ID token to the wallet, and this will basically create an Octo wallet for your user on our servers. An account abstraction wallet will be created on Polygon testnet, and the result, basically an address of the wallet address will be returned on which you can interact with. The basics call that we have given as of now is transfer funds and the get portfolio. Transfer funds allows you to transfer any ERC20 or native token from your users to a recipient wallet without any need of signing, because it is being managed internally by the Octo wallet and the platform. You can get the portfolio details using the get portfolio endpoint. You will get entire NFT portfolio and the token portfolio of the users, including the INR values for the user. In order for you to help in OAuth to ID token verification, we have given you the steps as well that you can use. It's pretty simple. You just need to go to your dashboard, the Google dashboard, and there you will be getting an ID token in return. And basically, this is a basic dashboard. You exchange the ID token, and you will be getting an ID token. You can use that directly in your app itself. This is the Octo wallet. I'll just briefly walk you through over the app itself, which is available at open source application. What we are basically doing is we are initializing Octo wallet in the main application initiation. Once it is initiated, the main activity is where you can start adding your functionality. You can start adding your UX on top of it. And this is internally basically calling all the functionalities. First one is ID token. You can, if for the sake of hackathon, if you're not able to log in or you're not able to initiate sign in with Google, what you can do is you can go to your developer profile, get an ID token, hardcode your ID token here, or maybe take it as an input from the user itself, and just bypass the authentication flow, and you can directly use the wallet SDK. Once you have authenticated the SDK, it creates a wallet, and if an wallet already exists, it will return the address itself. Post that, we have added multiple functionalities. These are buttons that you can use on top of it, which basically gives you an idea about what functionality the Octo wallet has. One that I have already discussed is transfer funds. You need to basically give the token address on which you want to, which ERC20 or native you're interacting with. For native, you can just leave it as empty. We'll take it as a native value. And you can give the recipient address as well as the quantity in decimals, 0.001. You don't have to worry about way or GoA conversion. And we will return you a job ID, and which internally manages, publishes a job, manages a transaction. If it drops, we retry it again. And once everything is completed, we will give you the complete transaction hash in your job status API. We are also giving you raw transaction API, which will allow you to interact with any other dApp or any NFT, any dApp that you are yourself building using the SDK. So as any EVM transaction goes, you just need to pass on 2 data value fields, and using those values, you will be able to interact with the Octo wallet on Polygon Mumbai on any dApp that is possible. Same lifecycle goes. You will get a job ID, you can monitor the status, get a transaction hash in return, and that's it. As you can see, you don't have to interact with any APIs regarding your portfolio, any RPC endpoints. You don't have to interact with any third-party tools like account abstraction builders or libraries. It's pretty straightforward, 6 APIs, 6 SDK calls, and you'll be able to do all the interaction that is possible. This is the Octo SDK in general. We will be also giving you the Octo SDK APIs. This internally is calling an API. There's nothing, SDK is just a wrapper over it. By tomorrow morning, you'll be having APIs as well. So if you're building on web apps, you can directly use it. One of our participants, as Neeraj also mentioned, that we are in alpha stage right now, and we are very closely working with the devs to make it happen. We are given 2 track prize for the problem statement. The first track prize is building a full-fledged app which has good UX, good user base, good user strategy as well, what they want to engage users with. And for them, what we are expecting is they are able to interact, they're able to create a wallet, they're able to perform basic token transfer, and they're able to host a app and also interact with it using the raw transaction endpoint, basically utilizing the whole full-fledged Web3 experience. For people who are beginners, they are just starting out, what they can use is they can basically, for the second track price, they can use the creation of wallet and basic token transfer endpoint to even make a good Web 2.5 dApp that exists out there. If you want web APIs, we will be also building up on top of web APIs, and we will be also giving sponsorship transactions. So you don't have to worry about gas even in testnet. We have sponsored gas payment, so your transaction will go through even if the user does not have any Matic. So that's it. People with Octo T-shirt will be roaming around the entire hackathon, and our devs are actively working with you guys alongside. If you have any difficulties, any issues, you can reach out to us 24/7, and we'll be working on top of it and resolving it as we go. Thank you guys. If you have any doubts, we can have Q&A.
Actually, I had one doubt.
Yeah.
So you basically told that this part is for Android. So as we can see, it is Android Studio. So what happens is like when we are doing the authentication, does it take us to some other wallet through some?
No, there's no redirection involved. If you're using the sample activity that is given, we are also provided a web demo. There's a demo that exists, video demo that exists on the ETH Global website. As you can see in the demo as well, what will happen is the user will be given a sign-in with Google, just like any OAuth happens. The user's email ID will be automatically detected. Once clicked on it, there will be no redirection involved. Your user will basically get a wallet directly.
So at the Android side, we don't have to install any kind of wallet.
No.
So
you have the SDK. The wallet will be embedded inside your app directly.
okay, I understand. So if I am making an app from user, what do I have to expect? Like for the wallet thing, we don't have to expect anything.
No, basically what will happen is, if you can see the very first point that I'm writing right here, Octo Wallet Authenticate. What it will be doing is, we have already implemented the sign-in activity. This is the actual part of Google sign-in, right? We will directly force the user to have a Google sign-in. Once the Google is signed in, the user is signed in basically, we will check if a wallet exists. If it already exists, good to go. Otherwise, we will give a login pin, set a login pin entry scheme for two-factor authentication. And that's it. The screen will come on top of your app itself. Once it's collapsed, you can use your SDK within the background. There will be no screen further.
So it's kind of like I do the Google authentication part as a user,
yes.
And that's it. All the other things you are managing for
Correct.
the wallet side.
Exactly.
So again, one more doubt. For now, what about like I'm making some transaction or contract calls. So what about like gas fees? You said all that you'll be handling from your
there's
part.
two parts to it. Like one of the fellow hackers here as of now, we had gasless in our timelines, in our roadmap directly. So we are in alpha, we'll be launching beta in 2 weeks. We had gasless that time in mind, but because of the feedback that we received from the developers that they might be looking for gasless and faucet, since it's testnet, we decided to why not sponsor all the gas. So even if the user does not have Matic, you can just basically airdrop some USDT. If you have your own ERC20, you can mint that. You can be rest assured the transaction will go through because we will be using the paymaster approach to have the gas.
So Google authentication and that's it.
That's it.
Thank you.
Done? Done now?